we owe a debt of gratitude to autistic people because their genome, their genetic makeup overlaps with the genetic makeup of people who have been inventing for the last 70 to 100,000 years. Human progress wouldn't have achieved what it has without autistic people.
Welcome to Brain Science, the podcast where we explore how discoveries in neuroscience are helping unravel the mystery of how our brain makes us human. I'm your host, Dr. Ginger Campbell, and this is episode 180. If you're curious about how your brain really works, this is the podcast for you. This month's episode is an interview with Simon Baron-Cohen about his new book, The Pattern Seekers: How Autism Drives Human Invention. I want to say up front, this is not an episode about autism. It is a discussion of two key human abilities, empathy and invention. Baron-Cohen has explored these abilities from a unique perspective that I'm eager to share with you. Before we jump into the interview, I want to remind you that you can get complete show notes and episode transcripts at brainsciencepodcast.com. Brain Science is produced independently and relies on the financial support of listeners like you. To learn more, please visit brainsciencepodcast.com/donations. Please feel free to send me feedback at brainsciencepodcast@gmail.com or post to the Brain Science Podcast fan page on Facebook. If you'd like to get show notes automatically every month, sign up for our free newsletter. You can do this on the website or text Brain Science to 55444. Brain Science, all one word, to 55444. I'll be back after the interview to review the key ideas and to share a few brief announcements. Simon Baron-Cohen, welcome to Brain Science.
Thank you, Ginger, for inviting me onto the show.
I'm really looking forward to talking to you about your new book, The Pattern Seekers: How Autism Drives Human Invention. But first, would you tell us a little bit about yourself and how you got interested in the brain?
Sure. So I'm a psychologist and I carry out research at Cambridge University, primarily into understanding autism. So that was my way into the brain, really, that I was fascinated by the different ways in which the brain can develop. And maybe part of what we'll talk about is this new concept of neurodiversity, the fact that there isn't a single way for the brain to develop. We all have different profiles of strengths and challenges, and autism is just one of many profiles. So that's the notion of neurodiversity.
So you basically got interested in autism pretty early in your career?
Yeah, I mean, I started off after I graduated from college as a teacher in a small unit for autistic kids. This was back in the 1980s when there wasn't much known about autism. And there were just 6 kids and 6 teachers. So it was very intimate, really getting to know a small number of kids in detail. And I was just fascinated by what seemed to be a kind of disconnect, that on the one hand, the kids were intelligent, they were curious about the world, they loved learning. On the other hand, they had real difficulty in social interaction, in communication, even in self-awareness. And so, it became a puzzle, a kind of scientific puzzle. How could somebody have very intact or even above average intelligence when it comes to understanding the physical world, the world of objects, but somehow really struggle to understand the world of people? Were they different brain circuits?
Could you just maybe start out by just giving us an overview of your book?
Sure. So my new book is called The Pattern Seekers, and it's asking a big question, which is there a link between autism and the very human capacity for invention? If you stop and think about what is a big difference between humans and all other animals, I'd say one big difference is that we can invent. And of course, if you look at other animals, you can see some forms of behavior which look like invention, Certainly lots of other animals, human animals, use tools, but for the most part, they're simple tools, like using a rock to crack a nut. Whereas if you look around the human world, even the fact that we're talking through Zoom right now is a recent example of invention. But the book argues that we've been inventing generatively, almost non-stop, for the last 70,000 to 100,000 years. So part of the book is trying to understand what is this capacity in the human brain that enables us to invent. And then it circles back to autism to see if there's a kind of special link.
I'm going to start out by just talking about the two key abilities that you argue evolved that make humans unique. One you call empathy. I guess everybody calls it empathy. And then this sort of new idea to me anyway of the systemizing mechanism. So could you give us a brief overview of each of these and explain why they're important?
Sure. So maybe we'll start with the second one, the systemizing mechanism. So in the book, I argue that around 70 to 100,000 years ago, there was a cognitive revolution. Something dramatically changed in modern Homo sapiens brain that just wasn't present in our ancestors, our Homo ancestors. So whereas Homo erectus, Homo habilis, even the Neanderthals were using stone tools, stone axes and hammers, when it comes to modern Homo sapiens at around that time, we suddenly see invention of complex tools. For example, the first bow and arrow dates to about 75,000 years ago. I would say that's an example of a complex tool. And the thinking behind inventing something like a bow and arrow is what I call if and then logic. So if I take a stretchy fiber and attach an arrow to it, and if I release the tension in the fiber, then the arrow will fly. So it's if and then. And I think this is what this is what the systemizing mechanism does. It looks for these special patterns in the world, if and then patterns, both to analyze the world, but also to play with these patterns, to invent new tools that could do work for us. And around that same time, we see the first signs of jewelry, for example. So what's been found in the archaeological evidence from about 70,000 years ago is a necklace. And again, if we think about the logic in the mind of the inventor, this necklace was made out of shells. And the inventor would have thought to him or herself, if I take these shells and I drill holes in each shell and I thread a thread through the holes, then I can make a necklace. So it's this if and then logic. And then about 40,000 years ago, we see the first musical instrument, at least that's been found in the archaeological record. It was a flute made out of a hollow bone. But once again, we think about the inventor using that identical logic that if I take a hollow bone and blow down it, and if I cover one hole, then it makes a particular note. And if I blow down the hollow bone and uncover the hole, then it makes a different note. So just using this algorithm, if and then, we see Homo sapiens inventing a new system, an instrument, a musical instrument, and indeed music itself, which is a system of notes, of keys, of sounds. So that gives you a little flavor of what I think changed in the evolution of the human brain, which allowed us to invent. But then around the same time, I argue a second cognitive revolution occurred, which was the evolution of the empathy circuit. So this was a separate circuit in the brain, which allowed us to think about our own minds and think about the minds of others. So suddenly we could take into account what another animal or another person was thinking, what they were intending, what they might know or believe, what they might feel. And also we could reflect on our own thoughts and feelings. And that circuit, I think we can infer its existence because when we think about that bone flute, we don't just need to answer the question, how could it have been made? But also, why was it being made? Was the maker wanting to communicate through music to an audience? Was the maker of the flute thinking about the effects of the music on the listener? And equally, when we think about the jewelry, that necklace, was the maker thinking about how they would be perceived by others? Or was the maker creating the jewelry maybe as a gift because they thought that somebody else might want it or like it or find it beautiful? So in the same artifacts that modern humans were making, we can see the existence of both the systemizing mechanism, which allowed unstoppable invention, and empathy, which allowed us to engage in much more complex social interaction.
What is the relationship between these two abilities?
So far, we've been talking about what we can infer from way back in evolutionary time, from whatever's survived in the record. But if we want to understand the relationship between these two systems, really we have to look at living people today and do tests. And we conducted a very big experiment. We call it the UK Brain Type Study. So it was conducted here in the UK. 600,000 people took part. It was an online study, and we asked people to fill in 3 questionnaires. One was called the Systemizing Quotient. So how interested are you in systems and patterns? A second one was called the Empathy Quotient. So how interested are you in people's feelings and thoughts, and how easily can you tune in to what someone might be thinking? And then the third was what we call the Autism Spectrum Quotient, which measures how many autistic traits you have. And amongst this big population study were also 36,000 autistic people. They also took these measures. What we found was that both empathy and systemizing fall on a bell curve in the population. We all can do these things. We can all look for patterns. We can all imagine someone else's thoughts and feelings. But some of us are just average, and some people are above average. And yet there are other people who struggle with one or other of these things. What we found was actually the higher you score on one, the lower you score on the other. So the better you are at systemizing, the more you struggle with empathy, and vice versa.
I'm going to break in here just for a minute to tell you about our sponsor, Text Expander. When you use Text Expander, you can say the right thing in just a few keystrokes. Better than copy and paste, better than scripts and templates. Text Expander snippets allow you to maximize your time by getting rid of repetitive things you type while still customizing and personalizing your messages. Text Expander can be used in any platform, in any app, anywhere you type. I use it every day, and if your work includes any kind of typing, I encourage you to give it a try. Take your time back in 2021 and increase your productivity with Text Expander. Visit textexpander.com/podcast for 20% off your first year. And don't forget to tell them that you heard about it on Brain Science. That's textexpander.com/podcast.
So the higher you score on systemizing, the more you struggle with empathy, and vice versa. The better you are at empathy, the more you struggle with seeing these if and then patterns. And we found a few other surprises in that big study. First of all, we found that people who work in STEM, science, technology, engineering, or math, obviously they scored higher on systemizing. That was no surprise. But the surprise was that they also had more autistic traits compared to people who don't work in STEM. So this was again telling us that there was a link between aptitude at seeing these patterns, at invention, and how many autistic traits you have. And then amongst those 36,000 autistic people, we found that they had a particular type of brain where they were much more interested in systems relative to their level of empathy, that their systemizing was either above average or even very high, whilst their empathy was just average or below. So what we were able to see in the big population study was that people have these different profiles. At the beginning of this conversation, I called it neurodiversity. We could see that some people were more biased towards systemizing. We call those type S. Some were more biased towards empathy. So we call those type E. Some people were kind of equal in both. We call them type B for balance. And then there were the extremes. And the majority of autistic people fell into type type S or extreme type S, that they were systemizing non-stop, looking for patterns as they go out in the world all the time, whilst they were struggling with empathy. And then, of course, there's the mirror image of those, the extreme of type E, people who empathize non-stop, always worrying about what other people are thinking about or feeling, but they may struggle to put together a gadget or to figure out how a new system works.
So I know that the focus of your new book is on this systemizing mechanism, but for the sake of completeness, I'd like to spend just a few more minutes talking about the empathy half. So could you give us a little overview of what we know about the so-called empathy circuits?
Sure. So empathy is a kind of umbrella term, but we know that it has at least two different components. One is called cognitive empathy, which is the ability to imagine what someone is thinking or feeling. The other is called affective empathy, which is having an appropriate emotional response to what someone else is thinking or feeling. And we know that autistic people, for example, struggle with the first component, with the cognitive empathy. So they might have difficulty in interpreting somebody's facial expression or reading their body language or simply imagining what they might be thinking. But they don't have trouble with affective empathy. They care about how other people feel. And if they hear that somebody else is suffering, it upsets them and they want to help. If you think about psychopaths or people with antisocial personality disorder, they almost have the reverse profile. They are very adept at figuring out what somebody else is thinking or feeling. That's how they might manipulate their victim, for example. But they don't really care about their victim's feelings, and that's how they can show cruelty.
Right. I like the example that you had in the book of Bill Gates, who we might think of as a hyper-systemizer, whether or not he's autistic, but he definitely has affective empathy when you consider that he's basically devoting the rest of his life and his fortune to trying to help people that are much less fortunate.
I would agree with that. We see through his philanthropy, through establishing his foundation, that he's really trying to help people and help the planet. He's clearly very good at systemizing. He built his career on that. And even reading his biographies or articles about him, he's got a fantastic memory for detail and for patterns. There's an interview with him where he talks about having memorized all the number plates of the cars in the car park so that he knew exactly when different employees were arriving or leaving. So he was able to spot patterns very easily. But yes, clearly his affective empathy is also very heightened. He wants to improve people's lives and improve the world.
So what are the skills that our empathy circuits make possible?
So the empathy circuit, I think, allowed a whole raft of new behaviors or skills. One of them was deception. As soon as you could sort of imagine what someone else might believe, you could also make another animal or a human believe something to be true when in fact it's false. And deception, although we think of it in negative ways in terms of morality, in fact, it's very advantageous. If you think about hunting your prey, building traps for animals that they might fall into the trap would have involved deception. Even the invention of the bow and arrow that we were talking about earlier is an example of what some people call a stealth weapon because it's silent. You're using an arrow that is a silent weapon from a distance to kill your prey. So that kind of deception would be possible with, it's sometimes called a theory of mind or cognitive empathy. But there are lots of positive aspects too. For example, teaching. We seem to be the only species that can teach in a flexible way. And teaching is all about keeping track of what the student needs to know. If you know that your child, for example, lacks certain kinds of knowledge, then you'll make the effort to teach the skill in ways that would be easy for the other person to learn. That's another consequence of being able to empathize. But there are many others, including communication, that of course many animal species have forms of communication. But what seems to kind of separate human communication from other animals is what's called flexible referential communication. That when we use a word or a gesture or a symbol, we intend our audience, our listener, to recognize our intention to use this symbol to refer to something. If I say the word cup, I intend you, the listener, to recognize that this sound, cup, refers to the particular object that I'm holding or I'm looking at, which contains coffee. So suddenly language could take off in a whole new way once we had empathy, because we could refer to objects in a flexible way or in a symbolic way. That's just one of the other consequences of the empathy circuit, but there are many.
You gave a very good overview of the systemizing already, but I wanted to ask, and you talked about the UK brain study, which was something that I intended to ask you about because it's a real important piece. How is it that we actually came to have these 5 different types of brains?
You might have imagined that the optimal kind of brain that evolution would have come up with would be the balanced brain, where individuals were equally good at empathy and at systemizing. But it turns out, when we look at the frequencies in the population, that most people are specialized in one direction or another. So about 30% of people in the population are type S, they're systemizers, more attracted to the world of abstract patterns or objects to understand how things work. Another 30% seem to be type E, or empathizers, kind of more tuned into people than to the world of objects. So it's only a minority, another 30%, who are balanced. So that suggests that natural selection may have favored individuals who specialized either to the world of people, navigating the social environment very easily with people skills, or natural selection favored brains that could understand objects and how they worked. And you could easily see how there would be advantages for a brain that was socially adept or a brain that was, if you like, mechanically or technologically adept. The brain that could tune into people might be very good at building relationships, which could come in very handy when you need a social network for support. A brain that was very good with people might have made better parents, looking after their offspring, because they could anticipate the needs of their young child, even before they can speak. But a brain that was more biased towards the world of objects and patterns in the environment might have also had an advantage in amassing resources, whether it was hunting, building new tools, building new weapons, resources that could have led to wealth and to greater resources, which we know is related to reproductive success. But all of these assumptions rest on the idea that both empathy and systemizing have a partly genetic basis. If natural selection, evolution, was shaping these skills, for that to be true, there must be a partly genetic basis to these skills. So what we were able to do in a second study, we called it the Genetics of Empathy and Systemizing study, was to ask people who took those questionnaires to also give us some of their DNA. And in these studies, we were working with over 50,000 people. You need big data to test for genetic associations with skills. And we worked with the company 23andMe that you may have heard of, which is a personal genomics company. You pay $100 and you can get a readout of your genetic code. And what we found was that indeed, both empathy and systemizing were partly genetic. So the genetic variation we were looking at was in what's called common genetic variants. So these aren't mutations. These are just variations in the genome that we all carry, but in certain combinations. And we found that there were some common genetic variants that were statistically associated with how you score on the empathy quotient and the systemizing quotient. And then again, the second big surprise for us was that if you looked at the genetic associations for people who were hypersystemizers, really good at systemizing, those genetic variants overlapped with the genetic variation that you see in autistic people. So even at the molecular level, not just at the cognitive level, but at the molecular level, we were seeing a link between autistic people and people who are strong at pattern recognition.
It sounds like pretty strong science to me.
Well, I think genetics, for me, that's kind of almost the bedrock of understanding humans and animals and the biological world. That's where things begin. And nowadays, what we've learned from the field of genetics and, with the new technology that exists, is you can look at either the whole genome or large chunks of the genome, and you have to do this at scale because each of those common genetic variants that we were talking about might only have a tiny effect on the brain and on behavior. But if you use large samples, 50,000 people, you can start to see those effects at a statistical level. And that just wasn't possible even 10 years ago. So partly it's about the progress that's been made in the field of genetics.
Would you like to talk a little bit more about this idea of neurodiversity and how it relates to our understanding of autism?
Yeah, so I think this is a really important, even revolutionary concept. People are beginning to talk about it. In fact, the concept or the word neurodiversity has been around for 10 or 20 years. But I'm pleased that employers are starting to think about it. So neurodiversity, as we said earlier on, is this idea that there isn't a single way for the brain to develop. We used to have this idea that there was a so-called normal brain, and that everything else was abnormal. And what we're doing is trying to move right away from that kind of binary distinction. In the UK brain type study, we saw at least 5 types of brain exist in any population, and that one isn't better or worse than another, they're simply different. And as we talked about, they may have evolved to be adapted to different environments, the world of people or the world of objects, for example. So what this means in terms of implications, both for kids and for adults, is that we need to provide environments that are inclusive for the diversity of brains that we will encounter. If we think about the classroom at school, as soon as kids start to go to school, the idea that we should simply have one teaching method and expect all kids to be able to learn in that environment just doesn't match what the science is telling us. Kids come with very different ways of learning, different learning styles. Some kids are going to learn better in social groups. Other kids are going to learn better, hands-on, doing little experiments, figuring out how things work just by playing with objects. And we need to make sure that the classroom caters for this diversity of learning styles. Autistic kids might really have a hard time if you put them into a classroom of, say, 25 kids, where they're expected to listen to information coming from a teacher, a human teacher. They may learn better in a much smaller group, maybe even in private study, private learning, and learning by doing, seeing what happens if I do this and I perform an operation and then I get a particular result. It's a very different way of learning to just listening to a teacher and looking at his or her face. And then in the world of work, I think we also need to think about neurodiversity because, well, let's take autism as just one type of brain out there. We know that autistic adults, the majority of them are unemployed. In the UK, the National Autistic Society, which is a charity, estimates some 85% of autistic adults are unemployed. I think it's almost a tragedy because if you're stuck at home, unable to work, we know that's not good for your mental health. You know, the isolation, the sense of exclusion from society, of not being valued, not having a salary, so not having any autonomy to get your independence. There's a whole set of factors that could lead to depression and anxiety, and that's what we see in the majority of autistic adults. You know, we have to stop and think, why are autistic people, many of whom are intelligent, they don't have learning difficulties, although that is seen in a minority. They have good systemizing skills. Why aren't they getting jobs?
Because they can do jobs that some of us would find incredibly tedious that they're good at. It's an untapped resource for a lot of the jobs that actually do exist today that need to be done.
Yeah, I think that's true. So there's an example that I cite in the book. In the Israeli army, they recruit autistic people into one particular unit because of their pattern recognition skills. And they show them hundreds or thousands of photographs of aerial footage, aerial photos, just asking the autistic soldiers in this case to just look to see if anything is unusual, if there are any patterns that don't seem to fit. And they're doing the same with CCTV, with film footage, because there may be some threat, some terrorist activity that autistic people might be particularly gifted at spotting, not because they know it's a military threat, but it's simply a pattern that is not the same as was there previously. So that's just one example, but you can imagine that any industry, any sector which involves systems, and most sectors do, could be a bicycle repair shop, it could be a bakery that follows particular recipes. These are all systems of one kind or another. And autistic people seem to be magnetically drawn to systems. They love the patterns. And part of systemizing is repetition, that you want to go over and over that pattern to see if you get the same result every time. So something that you and I might find boring, an autistic person might want to keep repeating. First of all, see if the pattern holds true, just like a scientist does. But secondly, to start playing with the variables, the if and then patterns. If I take a different ingredient and I put it into my recipe, then I get a different taste. So even in the world of cooking, which was a big leap forward in our evolution, the invention of cooking opened up new dietary opportunities, new health benefits, but equally we all enjoy cooking. We all enjoy the benefits of cooking. That is systemizing, and autistic people could be contributing to a whole range of jobs.
So I certainly hope that this information gradually gets out into the rest of the world. Simon, is there anything else that you'd like to share before we close?
So I think that, my book, The Pattern Seekers, is partly a new theory of human invention. I wanted to mention that this if and then pattern recognition was borrowed from a 19th century logician called George Boole, who many of your listeners will have heard of because he's credited with really understanding the logic that gave rise to the modern computer, amongst other things. And really what I've tried to do is think about how does the brain process these if and then patterns. So that's one side of the book, but I'm hoping that the book will also almost be a call for action, just as we were talking about. that we've got, 1 or 2% of the population, which is a substantial number of people worldwide who are autistic and yet who are languishing at home, unemployed, developing poor mental health, and as we're discovering, showing high rates of suicidality. Some 1/3 of autistic adults have attempted suicide. This is kind of like a human tragedy that's unfolding, because autism, if you're autistic, you're not born with poor mental health. The poor mental health is probably a consequence secondary to not having the proper support for your disability. And yet, according to this new book, we owe a debt of gratitude to autistic people because their genome, their genetic makeup overlaps with the genetic makeup of people who have been inventing for the last 70 to 100,000 years. Human progress wouldn't have achieved what it has without autistic people. That's the new claim. And yet we're leaving them outside of society.
Well, I'm really glad that I was able to read this book, Simon. It's very enlightening. Do you have any advice for students that might be interested in entering your field or students in general?
My main message to students is to always follow your curiosity, particularly when we're talking about students in the world of science. Science is all about if and then thinking. It's about making discoveries or understanding how a mechanism works. But it's key, whether we're talking about undergraduate level or at graduate level and beyond, to just follow your interests, follow your curiosity. I went into science because I was fascinated by a human condition, autism. And here I am 30, 35 years later, still fascinated, still just following my curiosity. That's what drives the study of science.
I don't know how it is in the UK, but here in the States, it's amazing that anyone becomes a scientist because the way they teach science in school, they're trying to keep that part a secret. They make it seem like it's a bunch of dry, boring facts.
Yeah, to me, this is another tragedy. Not really on the same scale as what we were talking about earlier, because it's not about mental health. But I agree with you, science can sometimes be very dry in the way it's taught. And yet, if we think about where did science come from, although we think of science as fairly recent, maybe around the time of the Industrial Revolution, in fact, it goes way back, 70 to 100,000 years ago, with invention and with discovery. You can do new things once you understand the pattern. I think kids should be learning science out in the world. They should be making things. They should be out in the garden, picking up rocks to see what they can discover, just kind of poking around and doing their own little experiments. I think, to me, that's the joy of science.
I agree. Well, thanks so much for taking the time to talk with me today.
Well, it's been a fun conversation, and I'm grateful to you for inviting me.
I want to thank Simon Baron-Cohen for taking the time to talk with us about his new book, The Pattern Seekers: How Autism Drives Human Invention. He has developed a compelling hypothesis that makes sense of the apparent paradox of autism. He also argues for finding ways to incorporate the talents of autistic people into our society, not only for their mental health, but for the benefits of humankind. Before I review the key ideas, I want to remind you that you can find complete show notes and episode transcripts at brainsciencepodcast.com. Brain Science is produced independently, and it relies on the financial support of listeners like you. You can learn more at brainsciencepodcast.com/donations. I'd love to hear what you think about this episode or anything else about brain science. Send me feedback at brainsciencepodcast@gmail.com. You can also post to the Brain Science Podcast fan page on Facebook. If you'd like to get show notes automatically every month, sign up for the newsletter. Just text the word Brain Science, all one word, to 55444. That's Brain Science, all one word, to 55444. There's also a link in the show notes and on the website. Baron-Cohen's hypothesis is simple and straightforward. He argues that around 70 to 100,000 years ago, based on current archaeological evidence, Homo sapiens developed two key abilities that set them apart from previous hominid species. These abilities were empathy and systematizing. I should mention that in the book, he gives an ample discussion of the evidence that these abilities are the result of different brain circuits. During the interview, he mentioned several studies involving large numbers of people, and these are also described in more detail in the book. One aspect of empathy, which he calls cognitive empathy, is commonly called theory of mind. This can be distinguished from affective empathy, which is having the appropriate emotional response to another person's thoughts and feelings. Autistic people struggle with cognitive empathy, while a lack of affective or affective empathy is often seen in psychopaths. Systemizing refers to the ability to see patterns, which is the first step toward actually inventing new tools and then constantly improving them. In the book, he describes some of the typical behaviors of autistic children from this perspective. For example, repeated behaviors are reframed as testing hypotheses. But probably the most important idea to remember from this episode is that Baron-Cohen's work has shown that the complementary abilities of empathy and systemizing are not only complementary, but being better at one correlates with being worse at the other. In general, those diagnosed with autism score high on systemizing and low on empathy, but we see the same diversity across the population. He hypothesizes that both were important to early survival of Homo sapiens, which would have selected for those who were extremely strong in one or the other. This is supported by the data that show only about 30% of people test out equal in both systemizing and empathy. There is also evidence that both empathy and systemizing have genetic origins, but this is not a surprise. Instead, a key idea is that there is no such thing as a single, quote, normal brain, because neurodiversity is normal. One point Baron-Cohen made repeatedly in the book that I don't think came up during our conversation was the point that the diagnosis of autism is only appropriate when a person is struggling and needs extra help. I would add that it makes little sense to go around labeling successful people as autistic based on some perceived deficit in their social skills. However, Baron-Cohen repeats the argument that we heard from Temple Grandin back in episode 99. Many autistic people can make valuable contributions. They should be assisted to reach their full potential, and they shouldn't be written off as disabled. One problem is that autism has become conflated with mental retardation, even though most people who meet the criteria for autism do not have true learning disabilities. This is a complicated issue that goes beyond the scope of today's episode. If this is a topic that interests you, I strongly encourage you to read The Pattern Seekers: How Autism Drives Human Invention by Simon Baron-Cohen. And share it with others, especially parents with autistic children. Dr. Baron-Cohen is probably the most highly respected researcher in autism, and there is way too much pseudoscience out there. I also want to mention that I discussed Temple Grandin's book, The Autistic Brain, way back in episode 98, and I interviewed her in episode 99. These episodes are available to premium subscribers, but I'm going to include her interview as extra content within the free Brain Science mobile app. All you have to do is look for the extras for this episode. I would love to hear your feedback about this episode. You can write to me at brainsciencepodcast@gmail.com. Also, please visit brainsciencepodcast.com for complete show notes and episode transcripts. Sign up for the newsletter to get free show notes every month. And don't forget to buy my book, Are You Sure? The Unconscious Origins of Certainty. I'll be back next month with another interview. In the meantime, please check out my other podcasts, Books and Ideas, and Graying Rainbows. Thanks again for listening. I look forward to talking with you again next month. Brain Science is copyright 2021 to Virginia Campbell, MD. You may copy it to share it with others, but for any other uses or derivatives, please contact me at brainsciencepodcast@gmail.com. The theme music for Brain Science is Mind Fire, written and performed by Tony Catraccia. You can find his work at syncopationnow.com.